Okay, hey everybody, this is a video to help you review some of the key points for Chapter 2. Alright, so we have a Chapter 2 reading assignment, and it sounds like it'd be simple. It's units. You've done units before, probably in high school, probably in physics or something. But, units is a big deal in engineering. There's a lot in Chapter 2, and it's important to rewind back to the basics and make sure we're on the same page about some of the basic ideas behind units and how we use units within engineering. Okay, so picking out some of the highlights of Chapter 2. Please watch this video, the rest of this video, try to take this in and have sort of the big picture in your mind, and this will let us start to tackle some actual problems in class on Friday. Alright, so in Chapter 2, he starts and he covers something that he calls base dimensions. Okay, so these are things like length and mass and time and temperature. Those are fairly obvious, but then when you get into electrical systems, there's the idea of current. Alright, and then not used quite so much, except when you get into chemistry, is the amount of a substance. We're talking about moles here, that kind of thing. And then, again, not as common, luminous intensity, sort of how much light is present. So these are some base dimensions. Alright, he keeps this in general, right? So we're not talking about SI units versus English units, we're just talking about just in general. Alright, so he comes up with a table, alright, and the table talks about derived dimensions as opposed to base dimensions. So we write derived dimensions in terms of base dimensions. Alright, so that's really pretty easy concept. So if you start with area, if you had a rectangle, and this is length times width, that gives you the area. So you'd have two length dimensions, so the basic unit of area is L squared. Alright, that makes sense to you, hopefully. Alright, let's do one more. How about force? What do you know from physics about force? Well, hopefully you know F equals ma, where m is in the unit of mass, and then acceleration is a length per time squared, meters per second, something like that. Okay, so this is the derived unit in general for force. Okay, so you see that here matches up. All right, so think through that, make sure you understand how we can get derived dimensions from base dimensions. All right, next the approach is, all right, we don't have to generalize this. We can now insert a particular system of units. So in this case, we're looking at SI units, all right, and you should memorize this, that length, the standard unit is meter. For mass, the standard unit is kilogram, so forth and so on for these base dimensions. Okay, from there, he talks about the advantages of the SI system. One of the big advantages is that the SI system is set up to where the units that we use can be very precise. We define them based on some of the physical properties of the universe. So for example, a meter, okay, we're looking at how far or how long it takes light to travel 1 meter, okay, and so we get the idea of how we would define this, and this would be very repeatable because the speed of light in a vacuum is very constant, and we would get a very precise measurement for that particular unit. All right, so interestingly enough, he talks about the exception for this being the kilogram. Okay, and he has a picture. I snarfed it out of the book. Here's a picture of a reference kilogram sample. This is supposed to weigh 1 kilogram, okay, being held at the National Institutes of Standards. Well, it turns out he's wrong because this book was written in 2014. In 2018, you can Google this, but the kilogram was actually defined in terms of physical constants of the universe. So that's just an interesting fact, and it's something to keep in mind when you read books that, information and knowledge keeps evolving, and we were able to systematically define a kilogram in terms of physical constants of the universe. Okay, the next thing I want you to look at is we're talking about SI units, and then remember we had derived units, basically derived dimensions in the previous table. Now we can use derived dimensions using SI units. Okay, so for acceleration, meters per second squared. Okay, for area, meters squared is the standard SI unit. All right, so you get the idea. You need to start learning to think in terms of fundamental dimensions and derived units. Okay, so there's an introduction to that. It turns out we use a lot of derived units so much that we give them a name. Okay, so for example, hertz is cycles per second, so the base unit is 1 over s, 1 over seconds. Okay, it would be a pain to write all these out every time, and so we name this the Newton for force. For energy, we use joule. Although there's lots of different ways we can express energy, and we'll talk about that as we go through the course. All right, so put that into your head and think about the significance of that we have named units, and those can be expressed into fundamental base units. All right, we can do the same thing with English units. You should know what these base dimensions are in their English units. Foot, slug. Slug is not something we talk about a lot, but you can read about it in the book. If you take, slug's a measure of mass. If you factor gravity into there, you get pounds. Okay? All right. That's the main thing I want to say about that. The next thing you really need to know, you need to memorize this table. Okay. PETA, not so much. That's not used all that much, but and down at the bottom, femto is not used so much. But everything in here, we use that quite a bit because of the scale of quantities. If you were trying to write, the size of the number of bits in a file, if you start using megabytes and gigabytes, that's much more compact way of writing it rather than keeping track of all the extra digits you would need without it. Okay. Those are the basic ideas. All right. We know, when you think of units, one of the things that you're talking about a lot is converting between systems of units. So, for example, metric over to English. We know certain conversion factors, and these are easy to look up these days. In fact, you can talk to Siri on the phone. It can make these conversion factors for you. But as engineers, it's important to know the process. Okay, so hopefully you'll take this to heart, and as you read through Chapter 2, focus on these main ideas. This idea of dimensional analysis, where you can break a fundamental dimension and represent other things like force in terms of those fundamental dimensions. All right, we have all kinds of formulas that we'll use in engineering, and you need to be able to break it down into the fundamental units.